I'm going to show you how to find percent composition for a compound. So here's the definition. It's just what it sounds like. It's the mass percent of each element in a compound. And those percentages, of course, will add up to 100%. So like, for example, if we had carbon dioxide, here's CO2, we would use the formula and we'd get the percent carbon and the percent oxygen, and that would add up to 100%. So how do we get those numbers? Well, let's do an example. This compound, copper 2 nitrate, is made up of copper, nitrogen, and oxygen. So what I want to do is first assume 1 mole. Let's say I have 1 mole of my compound. Well, if I have 1 mole of compound, I have 1 mole of copper, and then I have, 2 moles of nitrogen, and 2 times 3, or 6 moles of oxygen. It kind of looks like I'm about to calculate molar mass, doesn't it? Well, that's really the next step. Convert each of these numbers of moles, convert them to grams. So we're just going to multiply by molar mass. Okay, what's the molar mass of copper? And the molar mass of nitrogen. This is actually how I work problems. I write everything out and then I pick up the calculator at one time. Okay, so remember, molar mass is grams per 1 mole. So copper is 63.55, nitrogen is 14.01, and oxygen, one of the first ones you'll memorize, is 16. All right, so we're going to calculate these masses. Okay, we've got 28 grams of nitrogen, 2802. And then we've got 96 grams of oxygen. Okay, so I have the mass broken down of each of the parts, each of the elements. Now add them together just like you're going to do molar mass. 187.57 grams. Actually, that is the molar mass of copper nitrate right there. That is the molar mass. Okay, but I want percent. So how do I get the percent? Well, take the part that is copper, divide by the total, times 100. Okay, for the nitrogen, take the part that is nitrogen, divide by the total, times 100. Last one, the part that is oxygen divided by the total times 100. Okay, I'm going to flip to the next screen just to give you those answers. And I would find that it is 33.88% copper, and nitrogen is 14.94. Now, when you get to if there's 3 elements in there, and you get to the third one, you can cheat and just take 100 and subtract the other 2 percentages. That's totally fine, as long as you did things right. Okay. And why did I hold on to 4 sig figs on my percentages? Well, back here in my calculations, I had 4 sig figs in those numbers, and so I wanted to hang on to that precision. So your answer for percent composition are those 3 numbers. Okay, so it's the percent of each element in that compound. Now let's work one more little question, and just to give you a little thorough understanding. We have a compound containing only sodium and fluorine. 5 grams of the compound contains 2.26 grams of fluorine. What is the percent sodium? Well, I don't know how you see it, but I think I can find the percent that is fluorine really quickly. I know there's 2.26 grams of fluorine divided by total times 100. That would give me 45.2% fluorine. But that's not what the question was. The question was, what's the percent sodium? Well, if it only contains sodium and fluorine, then I know that 100 minus the fluorine percentage would give me the sodium, which is 54.8% sodium. Okay, so Mass percent problems are really pretty simple as long as you think things out, write things out, and hang on to your sig figs.